In this video, we're going to go over the basic techniques for solving the tangent equations that just have the form tan theta equals a. So we'll start with what we know. We know that if we had tan theta equal a, and we dig the theta out of here by taking the tangent inverse of both sides, we know that this is just going to give us a single angle. I'm going to call it theta sub 1. And the tangent inverse only gives us an angle between negative pi over 2 and pi over 2. And this is because we had to constrain the domain of the tangent function in order to define the inverse tangent function. So the angle is always going to be an angle between negative pi over 2 and pi over 2. In fact, it's going to be between, actually that should even be an open interval. It's going to give us an angle on the open interval from negative pi over 2 to pi over 2. In other words, it's going to give us an angle that's between these two vertical asymptotes of the tangent function. X equals pi over 2, or theta, if I'm working in a theta world, theta equals pi over 2, and theta equals negative pi over 2. It's going to give us an angle between negative pi over 2 and pi over 2, an angle somewhere in here. The key to remember with the tangent function is that the distance between any two vertical asymptotes is only pi radians, or 180 degrees. So the period of the tangent function is half that of the sine and the cosine function. This distance right here is only pi radians, or 180 degrees. So if you have the value a on the axis and you ask when will the tangent function equal a, you're looking for the intersections of the line y equal a with the tangent function. And the key for the tangent function is it's really simple. The distance between these is going to be a distance of one period. The distance between these intersections is just going to be one period. So for the basic tangent function, it's going to be pi radians, or 180 degrees between each point. That gives us an output of a. So to get all of the solutions for the tangent function is very straightforward. The principal solution is just tangent inverse of a, the angle between negative pi over 2 and pi over 2. But if you want to have all solutions, you just add any integer multiple of pi, so k has to be an integer, to the principal solution, and you're getting to the next angle at which the next angle for which the side ratio a is generated. So here's a simple example. It says find all solutions to the equation tan theta equals the square root of 3. So I've got tan theta equaling the square root of 3. So to dig theta out, I take the tangent inverse of both sides. Theta equals the tangent inverse of the square root of 3. And that's going to be this angle right here. That's an angle between negative pi over 2 and pi over 2. It's going to be an angle, we'll call it theta sub 1. Hi, I'm an angle theta sub 1, and the key is that all of these other guys are just a distance of pi radians from each other. So to get all solutions, I just go plus pi times k, where k is some integer. And then I just need to ask the question, is the side ratio square root of 3 associated with a special angle? In other words, is theta sub 1, the angle generating the side ratio square root of 3, is it a special angle or not? So if I go to the unit circle, my always wonderfully drawn unit circles, and I want to remember that the tangent function is defined to be the ratio of the y coordinate to the x coordinate. So on unit circle world, at 60 degrees, or pi over 3 radians, I would have the ordered pair x is a half, and y is root 3 over 2. And if I take the side ratio y over x for that angle, tangent of pi over 3, the side ratio would be root 3 over 2 over 1 half. And the 2's are both in the denominator, so we would get a 1, and we would get root 3 over 1 is just root 3. So pi over 3 is the angle that generates the side ratio square root of 3, and that's what the output to the tangent function is. It's the angle that generates this side ratio. So I'd step one more down, and I would say I actually can get this exactly using a special angle. The special angle that gets it is pi over 3 radians. So this theta sub 1 right here is actually pi over 3, which means this ordered pair, which GeoGebra gave me decimal approximations for, is pi over 3, comma, and the side ratio is the square root of 3. And it's plus pi times k to get to all of the other intersections. So different than the sine and cosine function in the sense that the period, which you have to add on to the tangent inverse to get additional solutions, the period is half that of the sine and cosine. Sine and cosine have a period of 2 pi. Tangent has a period of pi. Add a integer multiple of the period onto the primary solution in order to get all solutions to the tangent function.